What if their blood still runs through some of us today? The Sumerians called them the Anunnaki, figures of power whose true nature has been blurred by time. Their stories seep through stone tablets and temple walls, hinting at origins we can no longer fully see. Across the centuries, traces fade, questions multiply, and the trail grows colder. But the feeling remains. Whatever they were, the story isn't over, and it may still be unfolding around us. Whether you're here to learn, to wonder, or just to unwind, we hope this journey pulls you in. Let yourself be immersed in the mysteries of them. The dust was warm beneath Dr. Henry Hall's knees as he worked on the excavation grid at Tel al-Ubaid. The sun hung low over southern Mesopotamia, casting long shadows through the canvas shelter where the British Museum expedition had been methodically uncovering layers of ancient life. It was 1919, and each day brought artifacts from civilizations that had flourished thousands of years before recorded history. But what emerged from the cracked earth that morning would challenge everything archaeologists believed about humanity's earliest societies. Hall's brush moved carefully around the object, revealing details with each gentle stroke. The figurine was small, perhaps 6 inches tall, crafted from fine clay that had been fired to a warm, earthen hue. As more soil fell away, the craftsmanship became evident. This wasn't crude pottery thrown together by primitive hands. Every line showed deliberate artistry, every surface had been smoothed and shaped with precision. The figure wore elaborate robes, pleated and formal, suggesting ceremonial importance. But it was the head that made Hall pause. Where human features should have been, an elongated skull tapered to a narrow snout. Large, almond-shaped eyes dominated the face, their surfaces polished to an almost glass-like finish. The overall impression was unmistakably reptilian, yet the posture remained dignified, even regal. Cradled in the figure's arms was a smaller form, an infant, with the same otherworldly features nestled against the ornate robes in a scene of tenderness that spoke of maternal care. The stratigraphy was clear and undisturbed. Hall examined the soil layers with the trained eye of an experienced archaeologist. The figurine came from deposits that belonged firmly to the Ubaid period, dating between 5000 and 4000 BC. This placed it more than 1,000 years before the Sumerians would develop cuneiform writing and begin recording their stories of gods and kings. The people who created this artifact had no written language, no recorded mythology to explain what they were representing in clay. Yet here they were, creating detailed portraits of beings that looked nothing like themselves. Tel al-Ubaid sat in the heart of ancient Mesopotamia, nestled between the Tigris and Euphrates rivers in what would later become the cradle of civilization. The Ubaid culture represented one of humanity's first organized societies, complete with sophisticated irrigation systems, monumental architecture, and advanced pottery techniques. These were not primitive hunter-gatherers struggling for survival. They were the direct ancestors of the Sumerians, the people who would go on to invent writing, mathematics, and urban civilization as we know it. If the Ubaid people possessed such advanced artistic skills, capable of creating realistic representations in clay, why had they chosen to depict beings so fundamentally different from themselves? The most puzzling aspect was their distribution. Similar figurines appeared at other Ubaid sites throughout the region. At Eridu, the ancient city the Sumerians would later claim as the first settlement on Earth. At which would become one of Mesopotamia's greatest urban centers, and at several smaller sites scattered across southern Iraq. Their presence was notably limited to this specific area, in the heartland of what would become Sumerian civilization, but not in surrounding regions or contemporary cultures. This geographic concentration suggested the figurines weren't part of a widespread artistic tradition, but something unique to this particular place and time. Whatever they represented had significance for the people of this specific region during this specific period in history. The conventional explanation emerged quickly from academic circles. Scholars proposed that the figurines represented deities or spiritual entities from the Ubaid religious pantheon. The reptilian characteristics, they argued, served as symbolic markers of divine status, similar to how later cultures would depict gods with animal attributes. Perhaps serpents held sacred meaning for these ancient people, as they did in many subsequent religions. But this standard interpretation carried significant problems. If these were merely religious symbols, why the extraordinary attention to anatomical detail? The figurines showed careful observation of proportions, clothing, and facial features. The artists had clearly worked from some kind of reference, whether direct observation or deeply embedded cultural memory. The Ubaid culture showed no other evidence of reptilian symbolism in their art, architecture, or burial practices. The snake motifs that would later appear prominently in Mesopotamian religion were notably absent from the archaeological record of this earlier period. These figurines stood alone, without supporting context from the broader material culture. When compared to artistic traditions from other early civilizations, the Ubaid figurines occupied a unique position. Egyptian art from roughly the same period showed gods with animal heads, but these were clearly anthropomorphic, human bodies topped with the heads of recognizable animals like ibises, jackals, or falcons. The Egyptian approach suggested symbolic transformation, human forms enhanced with animal attributes to represent specific divine powers. The Ubaid figures were fundamentally different. They showed a complete integration of human and reptilian characteristics, as if depicting beings that naturally possessed both sets of features. This wasn't symbolic representation, it appeared to be portraiture. The level of artistic sophistication reinforced this impression. These weren't crude fertility idols or abstract representations of spiritual forces. They were portraits rendered with the kind of careful attention to detail that suggested the artists were working from direct familiarity. Every fold in the garments, every curve of the elongated skulls, every nuance of the strange but expressive faces spoke of knowledge rather than imagination. Some figurines showed clear evidence of social stratification. Certain figures wore more elaborate costumes, carried what appeared to be ceremonial objects, or were positioned in poses that suggested leadership. This implied not just the existence of these beings in Ubaid society, but their integration into positions of authority and respect. The context of discovery added another layer to the mystery. The figurines were found primarily in ceremonial locations, near temple foundations, in special burial sites, or in what appeared to be administrative buildings. They were not casual household items or children's toys, but objects of evident importance to the community. Someone had invested considerable time and skill in creating them, preserving them, and positioning them in places of honor. Whatever these figurines represented, they came from a time before recorded history. They stood at the very foundation of human civilization, silent witnesses to something that had been present at the dawn of organized society. Modern scholars continued to propose alternative explanations. Perhaps the figurines depicted shamans wearing ritual masks or costumes. Some suggested they might be purely fantastical, products of an artistic tradition whose meaning had been lost to time. But each explanation seemed inadequate when confronted with the evidence. If these were masks, where were the physical masks themselves? Archaeological excavations had uncovered numerous other artifacts from Ubaid sites, pottery, tools, jewelry, architectural elements, but no masks or costumes that matched the appearance shown in the figurines. If they were purely imaginary, what had inspired such particular and detailed imaginations? The features shown weren't generic or archetypal, but specific. The exact proportions of the elongated skulls, the precise shape and positioning of the large eyes, the particular way the reptilian and human characteristics merged. The mystery deepened when researchers began tracing cultural connections forward in time. The Ubaid people didn't vanish from history. They evolved directly into the Sumerians, who would dominate Mesopotamia for the next 2 millennia. The transition was gradual and continuous, with pottery styles, architectural techniques, and settlement patterns showing clear development from Ubaid origins. And in Sumerian mythology, recorded centuries later in cuneiform tablets, appeared detailed accounts of beings called the Anunnaki. According to these ancient texts, the Anunnaki were powerful entities who had descended from the heavens to guide human civilization. They were described as tall, wise, and possessed of knowledge that far exceeded normal human understanding. The Sumerian texts credited the Anunnaki with establishing the first cities, teaching humans agriculture and writing, and ruling as kings and queens in the earliest dynasties. Most intriguingly, some texts suggested that certain human bloodlines carried a special connection to these beings, a divine heritage that justified their right to rule over others. The geographic and temporal connections were precise. The Sumerian civilization emerged in exactly the same region where the Ubaid culture had flourished, and the transition period coincided perfectly with the development of the earliest urban centers. Could the Ubaid figurines represent an earlier memory of the same entities that would later be remembered and recorded as the Anunnaki? The possibility was startling in its implications. If the figurines were based on observation rather than imagination, then beings with distinctly non-human characteristics had been present in Mesopotamia during humanity's crucial transition from prehistoric to historic times. They had been there as the first cities rose from the alluvial plains, as agriculture replaced hunting and gathering, as the foundations were laid for everything we recognize as civilization. Today, visitors to the British Museum can see several of these Ubaid figurines in their permanent collection. They rest in climate-controlled display cases, accompanied by scholarly labels that describe them as ritual objects or religious figurines. The museum's interpretation follows conventional archaeological wisdom, suggesting they represent symbolic or spiritual concepts rather than literal depictions. But standing before the glass cases, looking into those large, unblinking eyes that seem to hold knowledge of something beyond the contemporary world, the official explanations feel curiously inadequate. The faces stare back through 5 millennia, their expressions neither benevolent nor threatening, but simply knowing. They seem to pose a question that academic archaeology has been reluctant to address directly. What if the earliest chapters of human civilization weren't written by humans alone? These ceramic portraits are evidence suggesting that the relationship which gave birth to civilization may have left other traces, other evidence, other bloodlines that have been carefully preserved through millennia of human development. The cuneiform tablet rests behind protective glass in the British Museum, its surface covered with wedge-shaped marks that catch the light at sharp angles. Each character was pressed into clay over 4,000 years ago, recording what scholars consider the oldest work of literature in human history. The Epic of Gilgamesh tells the story of a king who ruled the ancient city of Uruk around 2700 BC, but it opens with a description that has puzzled translators for generations. According to the text, Gilgamesh was 2/3 divine and 1/3 human. The fraction seems oddly specific for what most scholars interpret as poetic metaphor. Ancient literature typically deals in absolutes. Gods and mortals occupy separate realms with little mathematical precision applied to their intersection. Yet here, carved in humanity's first epic poem, was an exact ratio describing the biological composition of a historical king. Gilgamesh ruled during the early dynastic period of Mesopotamia, around 2900 to 2350 BC, when the Sumerian city-states were establishing the foundations of civilization. Archaeological evidence confirms that Uruk was indeed a major urban center during this time, with massive walls and impressive architecture that match the epic's descriptions. The poem wasn't pure fantasy, it was rooted in historical reality, telling the story of a real king who had ruled a real city. But what did it mean to be two-thirds divine? The Sumerian king list, another ancient document that chronicles the rulers of early Mesopotamia, provides additional context that deepens the mystery. This text, compiled from various sources and covering thousands of years of history, repeatedly uses specific titles to describe certain kings. Many rulers are identified as son of Anu or chosen of Enlil, referring to two of the most powerful gods in the Sumerian pantheon. Anu was the sky god, the supreme deity from whom the Anunnaki derived their name. Enlil controlled the earth and air, wielding authority over human affairs. To be called their son or chosen one wasn't simply an honorary title. In Sumerian culture, words carried precise meanings, especially in official documents that would be preserved for posterity. This pattern of divine lineage wasn't unique to Mesopotamia. Across the ancient world, rulers claimed descent from gods. Egyptian pharaohs traced their authority to Ra, the sun god. Japanese emperors claimed ancestry from Amaterasu, the goddess of the sun and universe. In Mesoamerica, kings and queens presented themselves as descendants of celestial beings who had come to Earth to establish order. Yet the Sumerian texts showed a notable difference in their approach to describing these relationships. While other cultures often used clearly metaphorical language, pharaohs becoming gods through ritual transformation, or rulers receiving divine mandate through ceremony, the Mesopotamian documents frequently presented genealogical information as straightforward biological fact. The Epic of Gilgamesh provides a clear example. Rather than saying Gilgamesh was blessed by the gods or chosen by divine will, it specifies his ancestry. His mother was Ninsun, a goddess, and his father was Lugalbanda, a mortal king. The text treats this mixed parentage as biological reality, explaining Gilgamesh's extraordinary strength, wisdom, and near immortality as the natural result of his divine heritage. This literal approach to divine ancestry appears throughout Sumerian literature. The Sumerian king list doesn't merely say that early rulers were favored by the gods. It traces specific genealogical lines connecting certain dynasties to divine beings. Some kings are described as direct offspring of Anunnaki, with their authority deriving not from conquest or election, but from inherited bloodline. The conventional academic interpretation treats these claims as religious symbolism. Scholars argue that ancient peoples used divine ancestry as a way to legitimize political power, creating myths that justified why certain families should rule over others. The mathematical precision of descriptions like two-thirds divine is explained as poetic embellishment, designed to make kings seem special without literal biological meaning. But when examined closely, Sumerian literature typically showed clear distinctions between metaphorical and factual statements. Religious texts used symbolic language when describing spiritual concepts, but historical documents maintained careful precision when recording genealogies, property transfers, and administrative details. The mathematical specificity of divine fractions suggests something beyond simple metaphor. Why describe Gilgamesh as exactly two-thirds divine rather than simply calling him godlike? Why maintain precise ratios when loose, symbolic language would serve the same political purpose? The precision implies measurement, as if divine heritage could be quantified and tracked through generations. Even more puzzling are the lifespan records preserved in the Sumerian king list. According to the document, rulers from the earliest periods lived for hundreds or even thousands of years. The first 8 kings who ruled before the Great Flood are credited with reigns lasting between 18,600 and 43,200 years each. While later kings show more human-scale lifespans, the transition appears gradual rather than sudden, suggesting a biological dilution over time rather than a simple shift from myth to history. Modern scholars typically dismiss these extended lifespans as mythological exaggeration, arguing that ancient peoples had no accurate way to measure time and often inflated numbers for dramatic effect. But the Sumerians were sophisticated mathematicians who developed accurate calendars and maintained detailed administrative records. Their precision in other contexts suggests they wouldn't casually inflate numbers without specific meaning. According to a writer named Zechariah Sitchin, his interpretation of these texts, the extended lifespans and divine fractions, make sense if viewed as records of genetic hybridization. Sitchin proposed that the Anunnaki had created human beings by combining their own genetic material with that of existing Earth species, but had also established breeding programs with selected human populations to create a ruling class. These hybrid offspring would have possessed longer lifespans, greater intelligence, and enhanced physical capabilities compared to pure humans. They would have formed a natural aristocracy, with their authority deriving from demonstrably superior abilities rather than mere political manipulation. Over generations, as their divine genetics became diluted through intermarriage with purely human populations, their lifespans and abilities would have gradually normalized. This interpretation suggests that the careful preservation of bloodlines wasn't simply about maintaining political legitimacy, it was about preserving actual genetic advantages. The practice of royal intermarriage, which appears consistently across ancient civilizations, may have served a biological rather than purely political purpose. Evidence for this interpretation can be found in the continuity of divine claims across Mesopotamian history. As Sumerian civilization gave way to Akkadian and later Assyrian rule, new dynasties consistently maintained their connection to the original divine bloodlines. Rather than abandoning Sumerian religious traditions, conquering peoples adopted and preserved them, suggesting these weren't merely cultural artifacts, but represented something of continuing practical value. The Akkadian king Sargon, who established the first multi-ethnic empire in Mesopotamia around 2334 BC, claimed descent from the same divine lineages that had legitimized Sumerian rulers. His successors maintained these genealogical connections, even commissioning new texts that traced their ancestry back to the original Anunnaki. Similarly, the Assyrian kings who later dominated the region continued to identify themselves as inheritors of divine bloodlines established in Sumerian times. They rebuilt Sumerian temples, preserved Sumerian texts, and maintained the religious traditions that supported claims of divine ancestry. This consistency across multiple cultures and thousands of years suggests something beyond mere political convenience. The concept of divine heritage also appears in the physical artifacts left by these civilizations. Royal seals, statues, and wall reliefs consistently depict rulers receiving symbols of authority directly from divine beings. These images show gods placing crowns on royal heads, handing scepters to chosen rulers, or standing in protective poses behind enthroned kings. The careful preservation of these bloodlines through controlled marriage practices appears throughout ancient history. Royal families consistently married within restricted circles, often choosing partners from distant kingdoms rather than local populations, suggesting they were maintaining something more specific than mere social status. This widespread pattern of blood preservation across cultures suggests a shared understanding that royal lineages carried something tangible and measurable, something that could be lost if not carefully protected. Today, a visitor to the British Museum can examine a cylinder seal from ancient Mesopotamia that shows a Sumerian king receiving the rod and ring of justice from the god Shamash. The scene is carved with the realistic detail that characterizes Mesopotamian art, showing the interaction between divine and human figures as a historical event rather than symbolic representation. The king appears to be receiving not just symbols of authority, but actual empowerment from a superior being with whom he shares genetic heritage. Looking at this ancient image, a modern viewer might wonder what happened to the bloodlines it represents. If the divine fraction recorded in texts like the Epic of Gilgamesh reflected actual genetic inheritance rather than religious metaphor, then traces of that inheritance might still exist in the world. The wind carries sand across the tells of southern Iraq, sculpting and reshaping the mounds that hide humanity's earliest cities. In the 1920s, this desolate landscape buzzed with activity as teams of workers moved methodically across the ancient site of Ur, their spades and brushes revealing treasures that had been buried for nearly 5,000 years. Each layer of earth removed brought them closer to the royal cemetery that would transform understanding of Sumerian civilization. Sir Leonard Woolley led the joint British-American expedition, representing both the British Museum and the University of Pennsylvania in what was considered the most ambitious archaeological undertaking of its time. The partnership brought together the finest minds in Near Eastern archaeology, equipped with funding and institutional support that promised comprehensive documentation of whatever lay beneath the desert. The discoveries exceeded all expectations. The royal tombs of Ur yielded golden helmets that caught the sun like captured fire, silver vessels crafted with impossible delicacy, jewelry that demonstrated artistic sophistication beyond anything previously known from the ancient world. Lyres decorated with bull heads emerged from the earth alongside game boards inlaid with precious stones, weapons of ceremonial beauty, and evidence of burial practices that spoke of a civilization far more complex than scholars had imagined. Most remarkable were the death pits surrounding the royal burials, chambers containing the remains of dozens of attendants who had apparently accompanied their rulers into the afterlife. The careful arrangement of these bodies, the presence of poison cups, and the orderly nature of what appeared to be voluntary mass suicide painted a picture of religious devotion and social organization that challenged conventional understanding of early human society. Woolley's team worked with meticulous care, photographing each discovery in situ, creating detailed plans of tomb layouts, and documenting the position of every artifact before removal. The expedition's methods represented the cutting edge of archaeological practice, promising complete records that would allow future scholars to revisit and reinterpret the findings for generations to come. But something went wrong between the desert and the archives. The excavation reports that reached London and Philadelphia between 1922 and 1934 told only part of the story. While the artifacts themselves were carefully catalogued and shipped to museums, the accompanying documentation began to show troubling gaps. Complete sections of field notes appeared to be missing. Photographs that were referenced in preliminary reports never made it into final publications. Most significantly, detailed anthropological analyses of the human remains, standard practice for excavations of this importance, were notably absent from the official record. What remained were summaries, carefully edited accounts that focused on artistic and cultural achievements while glossing over the physical characteristics of the people whose bones told their own story about ancient Mesopotamian society. The golden treasures were described in exhaustive detail, but the bodies that wore them became statistical abstractions rather than individual human beings with measurable, observable traits. This selective documentation stood in stark contrast to contemporary archaeological practice. Other excavations from the same period routinely included comprehensive anthropological sections describing skull measurements, bone structure, estimated heights, and other physical characteristics that helped reconstruct ancient populations. The absence of such data from the Ur reports was particularly glaring, given the expedition's emphasis on scientific rigor and complete documentation. Private correspondence and diary entries from expedition members hint at observations that never made it into public records. Woolley's personal notebooks, parts of which survive in scattered archives, contain cryptic references to unusual skeletal characteristics and measurements that require further verification. These fragments suggest that the physical anthropology data existed but was deliberately excluded from published accounts. The institutional context provides disturbing possibilities for why such exclusions might have occurred. During the 1920s and 1930s, major museums and universities maintained strict control over archaeological publications, with editorial boards that could suppress findings deemed inappropriate for public consumption. The rise of racial theories in Europe created a climate where certain types of anthropological data were considered politically sensitive, potentially leading to self-censorship or institutional pressure to omit controversial details. More troubling still is the pattern of missing documentation that goes beyond simple editorial decisions. Key field notebooks disappeared entirely from institutional archives. Photographic plates referenced in preliminary reports were never filed in the permanent collections. Maps showing the precise layout of burial chambers exist only in incomplete copies, with crucial sections obscured or cut away. The British Museum's records show acquisition numbers for materials that no longer exist in their collections. The University of Pennsylvania's archives contain catalogue entries for documents that cannot be located, despite systematic searches by multiple generations of scholars. War damage has been blamed for some of these gaps, with World War II cited as the cause of various archival losses. But the pattern of missing materials suggests something more selective than the random destruction caused by bombing or fire. The gaps appear in anthropological data, while artistic and cultural materials remain intact, implying that someone made deliberate choices about what should be preserved and what should disappear. The few surviving fragments paint a troubling picture of what might have been suppressed. Partial skeletal measurements indicate individuals of unusual height and build among the royal burials. References to atypical cranial development appear in notes that were apparently never meant for publication. Most intriguingly, there are oblique mentions of genetic characteristics that require consultation with appropriate authorities before release. These cryptic references take on new significance when considered alongside the broader patterns of missing evidence from Mesopotamian archaeology. Similar gaps appear in the records of other major excavations from the early 20th century, particularly those involving royal or religious sites where evidence of unusual human remains might have been discovered. The institutional machinery that controlled archaeological publishing during this period had both the means and the motivation to suppress inconvenient findings. Museum directors, university administrators, and government officials all had reasons to avoid publicizing discoveries that might challenge prevailing theories about human development or raise uncomfortable questions about the origins of civilization. The suppression wouldn't necessarily have required conspiracy or coordination. Individual researchers, aware of the political sensitivities surrounding racial and anthropological research, might have chosen discretion over accuracy. Editorial boards might have deemed certain findings too speculative for scholarly publication. Government agencies might have classified materials deemed sensitive to national interests. What should have been one of archaeology's most completely documented excavations became a case study in selective preservation, with the most intriguing questions left unanswered because the evidence needed to address them had been quietly eliminated. The consequences extend far beyond academic archaeology. The Royal Cemetery at represented one of the few opportunities to study the physical characteristics of individuals who claimed divine ancestry and ruled over the earliest urban civilizations. The documentation of their remains might have provided crucial evidence for or against theories about hybrid bloodlines, genetic anomalies, or other biological factors that could explain the persistent legends of divine kingship. Instead, visitors to museums today can see the golden treasures of displayed in climate-controlled cases, accompanied by plaques that describe the artistic achievements and cultural sophistication of Sumerian civilization. The humans who created and wore these treasures remain invisible, reduced to anonymous shadows whose physical reality has been systematically erased from the archaeological record. In the archives of the British Museum, rows of storage boxes contain the surviving documentation from Woolley's expedition. But among the numbered sequences, gaps appear where boxes should be. Empty spaces on the shelves mark where crucial documentation once resided, the original catalogue numbers visible but crossed out, the contents noted as missing or transferred to restricted access. The evidence is gone, buried a second time by human hands rather than desert sand. The questions that might have been answered by the Royal Cemetery of remain open, not because the data was never collected, but because someone decided it should not be preserved. And when modern science finally developed the tools to revisit these ancient mysteries, the opportunity for answers had already been eliminated. The preservation room hums with climate control systems that maintain perfect temperature and humidity for its ancient occupants. Behind reinforced glass, in specially designed archival boxes, rest the skeletal remains of Sumerian royalty, kings and queens who ruled the world's first cities over 4,000 years ago. Each container bears meticulous labels detailing provenance, excavation dates, and catalogue numbers, representing decades of careful curation by museum professionals. These bones hold secrets that previous generations of archaeologists could only dream of accessing. Since the late 2000s, advances in ancient DNA extraction and sequencing have revolutionized our understanding of prehistoric populations. Scientists have successfully recovered genetic material from Egyptian mummies, Neanderthal specimens, and even the famous Iceman Otzi, revealing migration patterns, family relationships, and genetic characteristics that reshape our understanding of human history. The technology exists to unlock the genetic secrets of Sumerian royalty. The preservation conditions are ideal, the institutional expertise is available. Yet these particular bones remain untested, their genetic information trapped in a bureaucratic maze that ensures they will continue to keep their secrets. The scientific community began pressing for DNA analysis of the royal remains in recent years, when the techniques for ancient DNA extraction became reliable enough to handle precious, irreplaceable samples. The potential discoveries were tantalizing. These weren't ordinary ancient people. They were the rulers who claimed divine ancestry, who established the first urban civilizations, who left behind texts describing their connections to gods who had descended from the heavens. Their genetic profiles could provide crucial evidence for or against the theories that had swirled around Mesopotamian civilization for decades. Were the royal bloodlines genetically distinct from their subjects? Did they carry unusual genetic markers that might explain their claims of divine heritage? Could their DNA reveal connections to other ancient populations, or provide evidence of the kind of genetic mixing described in Sumerian texts? A consortium of archaeologists and geneticists formally proposed a comprehensive DNA analysis of the royal remains. The proposal was meticulously prepared, addressing every conceivable concern about sample preservation, cultural sensitivity, and scientific methodology. But the Iraqi government's response was swift and final. The request was denied. The official reasons cited respect for cultural and religious sensitivities. The bones of ancient kings, authorities explained, deserved to rest undisturbed, free from the invasive procedures required for genetic analysis. This was presented as a matter of preserving the dignity of the dead and honoring the cultural heritage of Iraq's ancient civilizations. The explanation sounded reasonable until compared with the treatment of ancient remains elsewhere in the region. Egypt had permitted extensive DNA analysis of royal mummies, including comprehensive genetic surveys of pharaonic bloodlines that revealed detailed family trees and hereditary characteristics. Jordan had allowed similar studies of Nabatean remains. Even other Middle Eastern countries with strong cultural preservation traditions had found ways to balance scientific inquiry with respect for ancient peoples. Iraq's position stood alone in its absolute prohibition against genetic testing. No alternative proposals were entertained, no compromise solutions were offered, no criteria were provided that might allow future reconsideration as techniques became less invasive or more culturally sensitive. The refusal became more puzzling when examined in the context of Iraq's generally supportive attitude toward archaeological research. The country had welcomed international teams to study Mesopotamian sites, had collaborated on artifact preservation projects, and had shown enthusiasm for research that enhanced understanding of its ancient heritage. Only DNA analysis was categorically forbidden. The scientific community's initial disappointment gradually gave way to deeper concerns about the rationale behind the prohibition. If the goal was truly cultural preservation, why was genetic analysis specifically targeted while other forms of scientific study continued to receive support? Why were the bones of Sumerian royalty treated differently from other ancient remains found throughout the region? Alternative explanations began to emerge among researchers familiar with the political complexities of archaeological discovery. The genetic analysis of ancient royalty wasn't just an academic exercise. It had the potential to produce results that could be politically and socially disruptive, particularly if they supported unconventional theories about the origins of civilization or the nature of ancient ruling classes. If DNA analysis revealed that Sumerian royalty carried genetic markers not found in surrounding populations, it would raise uncomfortable questions about human development and the sources of early political authority. If their genetic profiles showed connections to distant populations or unusual characteristics that couldn't be explained by conventional models of human migration and development, the implications could challenge fundamental assumptions about human history. The potential for controversy was amplified by the political context of the modern Middle East, where questions of ethnic identity, territorial claims, and cultural heritage carry enormous political weight. Genetic evidence that suggested ancient Mesopotamian rulers were ethnically or biologically distinct from local populations could be weaponized by various political factions, creating conflicts that had nothing to do with scientific inquiry, but everything to do with contemporary power struggles. The institutional machinery that controls access to ancient remains has powerful incentives to avoid such controversies. Museum administrators, government officials, and academic institutions all benefit from maintaining stable relationships and avoiding research that might generate unwanted attention or political complications. The safest course is often to simply prohibit studies that might produce inconvenient results. This pattern of preemptive restriction isn't unique to Iraq. Across the world, access to potentially controversial ancient remains is controlled by bureaucratic systems that prioritize institutional stability over scientific discovery. The most interesting specimens, those that might challenge established theories or reveal uncomfortable truths about human development, are often the ones that remain permanently off-limits to genetic analysis. The Sumerian royal remains represent an extreme example of this institutional caution. These bones could potentially provide the most direct evidence available for testing theories about divine bloodlines, genetic anomalies among ancient rulers, and the biological reality behind mythology that has persisted for millennia. They sit in controlled environments, perfectly preserved and accessible to modern technology, yet protected by administrative barriers that ensure their secrets remain hidden. The preservation technology that keeps these remains intact also maintains the possibility that future political changes might allow genetic analysis. The bones are not degrading. They're waiting, suspended in climate-controlled limbo, for authorities who might be more willing to permit the scientific inquiry that current officials have deemed too dangerous to allow. But the pattern established by the refusal suggests that such permission is unlikely to come. The institutional forces that prohibited DNA analysis in 2011 have only grown stronger as the political complexities of genetic research have become more apparent. The same concerns about controversial results that motivated the initial prohibition continue to drive policy decisions about access to ancient remains. The bones of Sumerian royalty have become prisoners of their own potential significance. The more important their genetic information might be for understanding human history, the less likely it becomes that authorities will permit access to that information. They remain physically accessible but scientifically untouchable, their secrets protected by the same institutional caution that has shaped the archaeological record for more than a century. The parallel with the missing documentation from Woolley's excavations is unmistakable. In both cases, the most potentially revealing evidence about Mesopotamian civilization has been placed beyond the reach of scientific inquiry. Whether through deliberate suppression or administrative prohibition, the result is the same. Crucial questions about human development and the origins of civilization remain unanswered, because the evidence needed to address them has been systematically isolated from researchers. In the preservation room, a small vial containing bone fragments sits under controlled lighting, its label clearly marked with restriction codes that prevent unauthorized access. The remains inside could potentially revolutionize understanding of human history, but they rest in enforced silence, their genetic information trapped by policies that ensure they will never be allowed to speak. Looking at these sealed containers, a visitor might wonder how many other secrets lie protected by similar restrictions. If the bones of ancient Sumerian kings are considered too sensitive for genetic analysis, what other evidence remains hidden behind institutional barriers designed to prevent discoveries that might prove inconvenient to established theories or contemporary political arrangements? The vial sits on the laboratory counter, its contents a rich crimson that catches the fluorescent light. A small white label bears clinical notation, type O, Rh negative. To most observers, it appears identical to countless other blood samples processed daily in medical facilities around the world. But this particular vial represents something that has puzzled geneticists and anthropologists for decades, a biological mystery that challenges fundamental assumptions about human evolution and ancestry. Approximately 15% of the world's population carries blood that lacks the rhesus D antigen on the surface of their red blood cells. This absence, known as Rh negative status, creates a biological incompatibility that can have life-threatening consequences during blood transfusions and pregnancy. In medical terms, it represents a clear genetic boundary within the human species, a line that suggests not all humans developed along identical evolutionary pathways. The rhesus factor was named after the rhesus monkey, where scientists first discovered the protein during early blood typing research in the 1930s. The majority of humans carry this same protein, indicating a shared evolutionary heritage with other primates. But 15% of the population lacks it entirely, as if their genetic lineage had developed separately from the rest of humanity. This biological division creates practical problems that shouldn't exist within a single species. When an Rh-negative individual receives blood from an Rh-positive donor, their immune system treats the foreign protein as an invasion, potentially triggering fatal reactions. More puzzling still, when an Rh-negative woman carries an Rh-positive child, her body may produce antibodies that attack the fetus, treating her own offspring as a biological threat. This phenomenon, known as Rh incompatibility, occurs rarely in nature. Most species show remarkable biological compatibility between individuals, with immune systems that recognize genetic relatives as family rather than enemies. The fact that human reproduction can trigger such violent rejection responses within the same species suggests something unusual in our genetic history. The geographic distribution of Rh-negative blood reveals patterns that challenge conventional models of human migration and development. The highest concentrations appear in Western Europe, particularly among Celtic and Germanic populations, where rates can reach 25 to 30% in certain regions. Moving eastward, the percentages drop dramatically. In East Asia, Sub-Saharan Africa, and among indigenous American populations, Rh-negative blood is virtually non-existent, appearing only after European contact and intermarriage. This distribution pattern contradicts the out-of-Africa model of human evolution, which proposes that all modern humans descended from a small group that migrated from Africa between 60,000 and 70,000 years ago. If this were accurate, genetic traits like the Rh factor should show gradual variation across populations, not the sharp discontinuities observed in real-world data. The very low frequency of Rh-negative blood in most original African, Asian, and indigenous American populations suggests that this genetic variant was rare or absent in the majority of the founding groups that supposedly gave rise to all modern humans. Instead, it appears to have emerged specifically in European populations, then spread outward through conquest, trade, and intermarriage during historical times. This timeline creates significant problems for conventional anthropology. If Rh-negative blood resulted from random genetic mutation within early European populations, it should show the characteristic patterns of other beneficial mutations, gradual development, widespread distribution, and eventual adoption by neighboring groups through natural selection. In reality, Rh-negative blood remains concentrated in specific regions despite thousands of years of human migration and intermarriage. Its persistence suggests either remarkable resistance to genetic dilution or some unknown selective advantage that has maintained its frequency in European populations while preventing its natural spread to other continents. The medical implications add another layer to the mystery. Unlike most genetic variations, which either provide clear advantages or disappear over time, Rh-negative status creates significant biological complications without obvious benefits. The immune incompatibilities it generates would normally be selected against in evolutionary terms, yet the trait has persisted and even increased in frequency within certain populations. Some researchers have proposed that Rh-negative blood might provide resistance to certain diseases or environmental factors specific to European conditions. But decades of medical research have failed to identify any consistent health advantages that would explain its evolutionary persistence. If anything, the complications it creates during pregnancy and medical treatment should have reduced its frequency over time. The mystery deepens when examining the molecular biology of the Rh factor itself. The protein appears in all other primates and most mammals, suggesting it serves important biological functions related to red blood cell structure and stability. The complete absence of this protein in Rh-negative individuals represents not a minor variation, but a fundamental difference in cellular composition. Rh-negative individuals don't produce alternative proteins to replace the missing factor, nor do they show other genetic modifications that might explain how their red blood cells maintain stability without this apparently essential component. They simply function normally despite lacking something that appears necessary for proper blood cell development in other humans and related species. Conventional genetics explains this as the result of a deletion mutation that removed the gene responsible for Rh factor production. But the persistence and concentration of this defective gene in specific populations contradicts normal patterns of genetic drift and natural selection. Harmful mutations typically disappear from populations over time, while neutral ones spread randomly. The geographic clustering of Rh-negative blood suggests neither pattern. Alternative theories have emerged to explain these anomalies, some reaching beyond conventional anthropology into more speculative territory. According to certain interpretations of ancient texts and genetic evidence, Rh-negative blood might represent a genetic legacy from the period when the Anunnaki supposedly interacted with early human populations. This hypothesis suggests that the genetic incompatibilities observed in Rh-negative blood reflect biological differences between human and non-human lineages that merged during prehistoric times. If the Anunnaki possessed different cellular chemistry from Earthborn life, their genetic contributions might have created hybrid bloodlines that retained some characteristics of both parent species. The medical complications associated with Rh-negative blood could represent evolutionary mismatches, biological systems struggling to function with genetic material from incompatible sources. The immune rejections that occur during pregnancy and transfusion might reflect cellular recognition of foreign genetic signatures that persist even after thousands of years of interbreeding. This interpretation connects Rh-negative blood to the preserved bloodlines that appear throughout ancient history. From Sumerian kings who claimed divine ancestry to European royalty that maintained strict marriage restrictions, the pattern of genetic preservation might reflect practical knowledge about maintaining hybrid vigor while avoiding the complications that arise from incompatible genetic mixing. Modern blood banking illustrates both the uniqueness and the value of Rh-negative blood. Individuals with this blood type serve as universal donors for red blood cells, capable of providing safe transfusions to both Rh-positive and Rh-negative recipients. This biological universality creates a medical elite, a small percentage of the population whose blood can save others but who can only receive donations from their own kind. The rarity and medical importance of Rh-negative blood has created specialized donor networks and genetic registries designed to locate compatible donors when needed. These systems inadvertently recreate the kind of bloodline tracking that ancient civilizations used to maintain royal genealogies, identifying and cataloging genetic lineages for practical purposes. A world map showing the distribution of Rh-negative blood types reveals a pattern that seems too precise to be random. The highest concentrations cluster in specific regions of Western Europe, forming genetic islands that have remained stable despite millennia of human migration and conquest. Moving outward from these centers, the percentages decrease in concentric patterns that suggest not gradual evolutionary change, but discrete introduction followed by limited spreading. Why such a significant genetic variant would remain so geographically confined? If Rh-negative blood resulted from random mutation within early human populations, its distribution should show the gradual gradients typical of evolutionary change. Instead, it displays the sharp boundaries characteristic of genetic admixture, the mixing of previously separated populations with distinct genetic signatures. The pattern suggests that Rh-negative blood entered the human gene pool at specific locations and times, then spread outward through population contact rather than evolving independently in multiple regions. This distribution is consistent with the introduction of foreign genetic material into existing human populations, creating hybrid lineages that maintain some characteristics of both parent groups. Perhaps the answer to the Rh-negative mystery lies not in the laboratories where scientists study blood chemistry, but in the careful examination of populations that carry the highest concentrations of this unusual genetic trait. There exists a small community in Europe where Rh-negative blood occurs at twice the global average, a people whose genetic uniqueness extends far beyond their blood type into linguistics, culture, and physical characteristics that set them apart from all neighboring populations. Afternoon light filters through tall, narrow windows into the private archives of European nobility, casting geometric shadows across rows of filing cabinets that reach toward vaulted ceilings. The air carries the scent of old leather and preservation chemicals, a reminder that these documents have been carefully maintained for centuries. Many folders bear the distinctive red stamps that mark confidential materials, their contents restricted to authorized personnel and family members with appropriate clearance levels. These archives contain the medical and genealogical records of Europe's most powerful families, the Windsors, Habsburgs, Romanovs, and dozens of lesser houses that have shaped the continent's political landscape for generations. The documents trace bloodlines through marriages, births, and deaths that were carefully orchestrated to preserve what royal families have always called the purity of the line. But behind the formal language of royal succession lies a more complex story about genetic preservation that extends far beyond simple political tradition. European royal families have practiced endogamous marriage within closed family groups, for over 1,000 years. The Habsburg jaw, the bleeding disorder that plagued the Romanovs, and countless other hereditary conditions provide visible evidence of the genetic consequences of this intensive inbreeding. Yet despite these obvious risks, royal families continued these practices with a determination that suggests something more than political convenience was at stake. According to certain unconventional researchers, the persistence of royal inbreeding might reflect efforts to preserve genetic characteristics that were considered too valuable to dilute through marriage with common populations. These theorists point to the unusually high frequency of Rh-negative blood among European nobility as potential evidence that royal bloodlines carry genetic markers that distinguish them from ordinary human populations. The medical records that might confirm or refute such theories remain locked in private archives, protected by legal restrictions that prevent unauthorized access to royal genetic information. Unlike the genealogical records of other prominent families, which often become public after several generations, royal medical data is treated as state secrets that require the highest levels of security clearance. This exceptional level of protection becomes more puzzling when compared to the medical transparency shown by other aristocratic families. Noble houses without royal status often maintain public genealogies that include medical information, death certificates, and hereditary condition records that help researchers trace genetic patterns through European history. But families with royal status consistently maintain absolute privacy about medical details, even for members who died centuries ago. The legal framework protecting royal medical privacy varies by country, but the effect is remarkably consistent across different monarchies. In Britain, royal medical records are classified under the Official Secrets Act. In Spain, they fall under state security provisions. Former royal families in countries that no longer have monarchies often maintain similar restrictions through private trusts and foundations that control access to family archives. These restrictions extend beyond simple privacy protection into active suppression of information that might already be in the public domain. Genealogical researchers have documented cases where royal blood type information that was previously published in medical journals or historical accounts has been quietly removed from subsequent editions. Academic papers that referenced royal genetic data have been withdrawn from circulation or heavily edited to remove specific medical details. The pattern suggests institutional coordination designed to prevent the accumulation of genetic information about royal bloodlines. While individual pieces of medical data might seem harmless in isolation, their systematic collection could potentially reveal patterns that royal families prefer to keep hidden from public scrutiny. One of the most significant gaps in available data concerns blood type distribution among European royalty. Despite centuries of medical attention and the routine nature of blood typing in modern healthcare, comprehensive information about royal blood types remains surprisingly difficult to obtain. The few documented cases of Rh-negative blood among royal family members are typically mentioned briefly in medical reports before disappearing from subsequent historical accounts. The House of Windsor provides a particularly striking example of medical secrecy. Despite extensive public interest in royal health and genealogy, specific blood type information for family members is consistently classified as private medical data. This restriction applies even to deceased members whose other medical information has been released for historical research. The selective nature of this privacy suggests that blood type data is considered uniquely sensitive compared to other genetic information. Similar patterns appear in the medical records of other European royal houses. The Habsburgs, whose genetic history has been extensively studied due to their famous hereditary disorders, show curious gaps in their medical documentation precisely in areas that would reveal blood type distribution. The Romanovs, whose tragic end has made them subjects of intensive forensic investigation, had their blood types determined during DNA identification procedures, but this information was classified and never released to researchers studying Russian royal genealogy. These restrictions take on additional significance when considered alongside the historical marriage patterns that royal families have maintained. The preference for marriage within restricted circles wasn't limited to maintaining political alliances. It often involved seeking partners from geographically distant royal houses rather than marrying into local nobility. This suggests that royal families were preserving specific genetic characteristics that could only be maintained through careful partner selection across international bloodlines. The genetic isolation maintained by royal marriages becomes even more remarkable when considered alongside population genetics research that shows most European nobility carry genetic markers indicating substantial mixing with local populations over time. Royal families appear to be exceptions to this pattern, maintaining genetic distinctiveness that suggests either remarkable discipline in marriage partner selection or the preservation of characteristics that were considered worth the obvious risks of inbreeding. The preservation of these genetic patterns appears to have been carefully guarded and passed down through generations of royal advisors and court physicians who maintained detailed records of family medical histories. These records formed the basis for marriage decisions that successfully preserved genetic characteristics across centuries of political upheaval and social change. The institutional machinery that currently protects royal medical privacy represents the modern evolution of this ancient system of genetic secrecy. The same careful record-keeping that once guided royal marriage decisions now operates to prevent public access to information that might reveal the biological foundations of royal authority. The security measures protecting royal genetic information often exceed those applied to actual state secrets. Medical records that could revolutionize understanding of European population genetics remain locked in archives, while less sensitive political and military documents from the same periods are routinely declassified for historical research. This level of protection suggests that royal genetic information is considered more potentially damaging than conventional state secrets. The implication is that public knowledge of royal blood type distributions or other genetic characteristics could somehow threaten the institutional foundations of monarchy itself. We might wonder what patterns would emerge if the genetic data of all European royal families could be analyzed together. If the blood type distributions and other hereditary characteristics of royal bloodlines were mapped comprehensively, would they reveal evidence of the genetic preservation, or would they show normal human variation that happened to be concentrated through centuries of careful breeding? The answer lies locked behind institutional barriers that treat royal genetic information as too dangerous for public knowledge, ensuring the biological reality behind centuries of claims about royal blood will remain hidden in archives where data exists but cannot be accessed or analyzed. Morning mist clings to the valley floors of the Pyrenees as ancient stone villages emerge from the shadows, their streets marked with signs in Euskera, a language that shares no linguistic heritage with any other tongue spoken in Europe. These settlements have stood unchanged for centuries, home to a people whose genetic and cultural distinctiveness has puzzled researchers since the first anthropologists began mapping European populations in the 19th century. The Basque people represent more than a linguistic curiosity. With Rh-negative blood frequencies approaching 35%, more than double the global average, they form a genetic island that challenges conventional models of European population development. Their traditions, customs, and oral histories preserve elements that seem disconnected from the cultural evolution that shaped neighboring societies, suggesting descent from populations that developed along fundamentally different pathways. This extraordinary distinctiveness did not escape the attention of European anthropologists during the early 20th century, when racial theories and population studies dominated academic research. The Basques represented a living laboratory for understanding human diversity, offering researchers the opportunity to study a seemingly pure European population that had maintained its characteristics across millennia of potential mixing with surrounding groups. During the 1930s, German scholars working under government sponsorship led teams that measured skulls, recorded linguistic variations, photographed individuals and families, and collected biological samples with systematic thoroughness that represented the cutting edge of anthropological methodology. The scope of data collection was extraordinary. Thousands of pages of measurements, hundreds of photographs documenting physical characteristics, detailed genealogical charts tracing family relationships, and extensive recordings of linguistic variations across different Basque communities. The researchers compiled what amounted to a complete anthropological profile of the Basque population as it existed before the upheavals of World War II archives. From the period document the ambitious scale of these projects. Research teams spent months in Basque villages creating comprehensive records that captured not just individual characteristics, but community-wide patterns of inheritance, social organization, and cultural practice. The resulting documentation promised to provide definitive answers about Basque origins and their relationship to other European populations. But these records, along with the institutional framework that created them, disappeared in the chaos that followed the war. Post-war inventories of anthropological archives reveal systematic gaps where Basque research materials should be located. Entire filing systems that once contained detailed measurements and photographs are missing from institutional collections. Reference catalogues list materials that cannot be found despite exhaustive searches by multiple generations of researchers attempting to reconstruct the lost data. The few surviving fragments paint a picture of what was lost. Scattered copies in smaller regional museums contain partial photographic collections and abbreviated measurement tables that hint at the comprehensive nature of the original research. These remnants suggest that the pre-war studies had documented physical and genetic characteristics that set the Basques apart from all other European populations in ways that went far beyond blood type distributions. But the fragments are insufficient to reconstruct the complete picture. Like archaeological shards that suggest the shape of a broken vessel without providing enough pieces to restore its original form, the surviving Basque documentation tantalizes researchers with hints of discoveries that can no longer be verified or fully understood. The loss becomes more significant when considered alongside the changes that have affected Basque populations since 1945. Migration, intermarriage, and cultural assimilation have introduced genetic and cultural elements that weren't present in traditional Basque communities. The population that researchers can study today represents a diluted version of the genetic and cultural distinctiveness that characterized pre-war Basque society. Modern genetic studies of Basque populations consistently show evidence of recent admixture with surrounding European groups. While the Basques still maintain higher frequencies of distinctive genetic markers compared to neighboring populations, the sharp boundaries that once defined Basque genetic identity have become blurred through decades of mixing with non-Basque populations. This means that contemporary research cannot simply replace the lost pre-war data. The population that exists today is fundamentally different from the one that was studied in the 1930s, making it impossible to verify or refute the conclusions that might have been drawn from the original comprehensive surveys. The timing of the data loss creates particular problems for researchers interested in testing theories about ancient genetic legacies. The pre-war Basque population represented the closest approximation available to the original genetic characteristics that had distinguished this group for thousands of years. The comprehensive documentation of that population might have provided crucial evidence for or against theories about hybrid bloodlines, ancient genetic modifications, or other unconventional explanations for Basque distinctiveness. Without access to baseline data from the pre-war population, contemporary researchers cannot determine whether current genetic patterns represent ancient inheritance or recent evolutionary changes. The lost archives contain the only comprehensive record of Basque characteristics before modern influences began reshaping the population, making them irreplaceable for understanding the true nature of Basque genetic heritage. The implications extend beyond Basque studies into broader questions about ancient populations and their potential connections to unconventional theories about human development. Researchers attempting to test hypotheses about Anunnaki bloodlines or other ancient genetic influences face a systematic problem. The populations that might provide crucial evidence are either inaccessible to modern study or have been so altered by recent changes that they no longer represent their original characteristics. For researchers interested in ancient genetic influences, the loss of Basque documentation creates a particularly frustrating gap. The Basques represent one of the few modern populations that might carry relatively pure genetic legacies from prehistoric times. Their extraordinary genetic distinctiveness, combined with cultural traditions that preserve memories of divine visitors and hybrid bloodlines, makes them crucial for testing theories about ancient genetic modifications. But comprehensive study of their original characteristics requires access to both pre-war Basque data and ancient DNA from populations like the Sumerians, who might share genetic heritage with Basque ancestors. Yet the access to ancient Mesopotamian DNA remains blocked by institutional barriers that prevent the kind of comparative analysis that could potentially reveal genetic connections between ancient and modern populations. The result is a research dead end where crucial questions cannot be answered because the necessary data exists on both ends of the investigative chain but remains inaccessible due to different types of institutional obstacles. The Basque archives were lost to historical circumstances, while access to ancient DNA is blocked by contemporary bureaucratic restrictions. The evidence needed to test unconventional theories about human development consistently remains beyond the reach of researchers who might use it to challenge established paradigms. In a storage room of a regional museum, wooden filing cabinets line the walls with labels that bear faded Euskira text marking where comprehensive anthropological records once resided. The drawers slide open to reveal empty spaces where thousands of pages of measurements, photographs, and genealogical charts should be preserved for future researchers. Somewhere in those missing files might have been the evidence needed to resolve fundamental questions about Basque origins and their potential connections to ancient populations. Looking at these vacant storage spaces, a researcher might wonder what patterns would have emerged if the complete Basque data could be compared with genetic profiles from ancient Mesopotamian populations. If both ends of this investigative thread remained intact, would they reveal connections that could transform understanding of human development and the nature of genetic diversity? The black and white photographs span centuries, collected from archives, private estates, and historical societies across the globe. Each portrait captures individuals who somehow stood apart from their contemporaries, not through clothing or status symbols, but through subtler characteristics that marked them as different. Unusual height, distinctive facial structure, eyes that seemed to hold knowledge beyond their years. They were kings and advisors, merchants and scholars, individuals who rose to positions of influence despite coming from unremarkable backgrounds. What united these figures wasn't their social position or historical significance, but their apparent possession of characteristics that shouldn't have appeared naturally in the populations they came from. They represented what unconventional researchers have termed hybrids, individuals who supposedly carried genetic material from both human and non-human sources, giving them advantages that allowed them to excel in ways that pure humans could not. According to this theory, the Anunnaki didn't simply create human beings and then withdraw from Earth. Instead, they established ongoing breeding programs with selected human populations, creating hybrid offspring who possessed enhanced intelligence, physical capabilities, and longevity compared to purely human bloodlines. These hybrids were placed into positions of leadership and authority, where their superior abilities would naturally elevate them above their purely human contemporaries. The concept explains persistent historical patterns that conventional anthropology struggles to address. Throughout recorded history, certain individuals have demonstrated capabilities that seem to exceed normal human ranges, and they mastered complex knowledge systems, built technological marvels, and established political structures that endured for centuries. They appeared to possess intuitive understanding of mathematics, astronomy, and engineering principles that their societies hadn't yet developed through normal cultural evolution. These exceptional individuals often claimed divine ancestry or special connection to gods, but modern interpretation suggests they might have been literally describing their hybrid heritage. The divine blood that legitimized their authority wasn't metaphorical. It was the genetic legacy of Anunnaki ancestors who had contributed non-human DNA to their family lines. Sumerian texts provide detailed descriptions that support this interpretation. The Epic of Gilgamesh describes its hero as 2/3 divine and 1/3 human, possessing strength and wisdom that exceeded normal human capabilities. Other Mesopotamian texts describe kings and heroes who were taller, stronger, and longer-lived than their subjects, with physical characteristics that set them apart from ordinary people. These weren't symbolic descriptions of political or spiritual superiority. They appeared to be literal accounts of biological differences that were obvious to contemporary observers. The texts describe specific physical traits, behavioral patterns, and capabilities that distinguished hybrid individuals from purely human populations. Modern anthropological evidence supports the possibility that such distinct populations existed in ancient times. Archaeological excavations have uncovered burial sites containing remains of individuals whose physical characteristics fall outside normal ranges for their historical periods. These burials often show evidence of high social status, with grave goods and burial practices that suggest the deceased held positions of special importance in their communities. The most intriguing cases involve skeletal remains that show combinations of characteristics not typically found together in human populations. Unusual cranial capacity paired with distinctive bone structure. Evidence of exceptional height combined with anatomical features that suggest different developmental patterns. These physical anomalies appear most frequently in burials associated with ruling classes or religious hierarchies. Contemporary population genetics reveals patterns that echo these ancient anomalies. Certain modern populations carry genetic markers that appear to be extremely ancient, predating the supposed arrival of modern humans in their regions by tens of thousands of years. Other groups show genetic variants that have no clear relationship to surrounding populations, as if their ancestors had acquired genetic material from unknown sources. The concentration of unusual genetic traits in specific populations becomes even more remarkable when considered alongside their persistence over time. While most genetic variants spread gradually through populations or disappeared due to natural selection, these particular characteristics have remained concentrated in isolated groups that have maintained their distinctiveness despite centuries of potential mixing with neighboring peoples. The Basque people represent perhaps the clearest example of this pattern. Their extraordinarily high frequency of Rh-negative blood, their linguistic isolation, and their genetic distinctiveness from all surrounding European populations suggest descent from a group that developed separately from normal human evolution. Their cultural traditions preserve memories of divine visitors and hybrid bloodlines that mirror accounts found in ancient texts from completely different regions. Similar patterns appear in other isolated populations around the world. Certain Native American groups carry genetic markers that don't fit standard models of New World colonization. Some African populations show DNA variants that suggest mixing with non-human species that supposedly went extinct long before modern humans evolved. Mountain peoples in various regions maintain traditions of divine ancestry that are accompanied by genetic evidence of unusual hereditary characteristics. These populations share more than just genetic anomalies. They also show consistent patterns of cultural and technological achievement that exceed what would be expected from their environmental circumstances. They developed sophisticated astronomical knowledge, advanced agricultural techniques, and complex social organizations that rival those of much larger civilizations. The correlation between genetic distinctiveness and cultural achievement suggests that the unusual genetic characteristics carried by these populations provided real advantages in cognitive ability, physical capability, or other traits that contributed to their society's success. These weren't random genetic variants, they were purposeful genetic modifications that enhanced human capabilities in specific directions. Conventional science explains these patterns through various mechanisms involving natural selection, genetic drift, and environmental adaptation. Isolated populations supposedly develop distinctive characteristics through random evolutionary processes that happen to produce advantageous traits. The cultural achievements of these groups are attributed to environmental factors that favored particular types of knowledge or social organization, but these explanations struggle to account for the specificity and persistence of the genetic patterns observed. Random evolutionary processes typically produce gradual changes that spread through populations over time. They don't usually create sharp genetic boundaries that persist for thousands of years despite opportunities for mixing with neighboring groups. The technological and cultural achievements of genetically distinctive populations also challenge purely environmental explanations. Many of these groups developed similar sophisticated knowledge systems despite living in completely different environments and having no contact with each other. The parallel development of complex astronomical knowledge, mathematical concepts, and agricultural techniques across isolated populations suggests access to information sources that weren't available through normal cultural evolution. Archaeological evidence supports the possibility that these populations maintained contact with non-human entities long after such contact ceased elsewhere. Sites associated with genetically distinctive groups often contain artifacts and architectural features that demonstrate knowledge of principles that supposedly weren't discovered until much later periods. They show evidence of technological capabilities that exceed what should have been possible given their apparent resource limitations. The genetic legacy of ancient hybrid programs may still be detectable in modern populations. Advances in DNA sequencing and population genetics are revealing previously unknown genetic variants that don't fit standard models of human evolution. Some of these variants appear to be extremely ancient, possibly predating the emergence of modern humans entirely. Other genetic discoveries suggest that human evolution involved more complex mixing events than previously understood. Evidence for interbreeding with Neanderthals and Denisovans has already required revision of human evolutionary models. Additional mixing events with unknown species or subspecies could potentially explain genetic variants that currently have no clear evolutionary origin. The institutional resistance to genetic research on ancient royal remains and modern elite bloodlines suggests that such discoveries might reveal patterns that authorities prefer to keep hidden. If comprehensive genetic analysis revealed that political and economic elites carry distinctive genetic markers not found in general populations, it could provide direct evidence for theories about hybrid bloodlines and their role in human societies. The implications extend beyond academic questions about human evolution into contemporary concerns about power structures and social organization. If current elites represent the continuation of ancient hybrid bloodlines, their authority might derive from biological advantages rather than democratic legitimacy or economic achievement. Modern technology makes it possible to test these theories directly through genetic analysis of individuals from families that claim ancient bloodlines or show evidence of unusual hereditary characteristics. The techniques exist to identify genetic markers that could distinguish hybrid populations from purely human ones. But access to the necessary samples is consistently blocked by institutional barriers that prevent such research from being conducted. The same pattern of evidence suppression that has characterized this investigation from its beginning continues to operate in the present day. Ancient archaeological records disappear. DNA analysis of historical remains is prohibited. Modern genetic data is classified as confidential. Each barrier ensures that crucial questions about human origins and the nature of contemporary power structures remain unanswered. In a conference room where world leaders gather to address global challenges, television cameras capture the faces of individuals who shape policies affecting billions of people. The lighting casts sharp shadows that emphasize the bone structure and facial characteristics of these powerful figures. Some show the distinctive features that have marked ruling classes throughout history. The elongated skulls, the penetrating eyes, the subtle physical traits that set them apart from the populations they govern. Looking at these faces, a careful observer might notice patterns that echo the ancient portraits found in Mesopotamian temples and Egyptian tombs. The same genetic signatures that mark divine kingship in antiquity may still be visible in the bloodlines that have maintained their authority across millennia of political change. If the hybrid theory is correct, then the question isn't whether non-human genetic material influenced human development in the distant past. It's whether that influence continues to shape human society in the present. The individuals who control governments, financial institutions, and international organizations might represent the modern continuation of bloodlines that were established through deliberate genetic modification thousands of years ago. The evidence assembled across these chapters suggests that human civilization developed not in isolation, but through ongoing contact with entities that possessed superior knowledge and different genetic characteristics. The traces of that contact persist in archaeological artifacts, genetic anomalies, and institutional patterns that continue to influence contemporary society. Perhaps the ultimate question isn't whether humans are alone in the universe, but whether we are living in a world that is truly human, or one that has been shaped by hybrid bloodlines that successfully integrated themselves into human society while maintaining their genetic and cultural distinctiveness across thousands of years of apparent human history.